Hi, Chris Good here, and we're going to use SPSS to do a few different types of correlational analyses. So we're going to calculate some correlation coefficients. I'm going to start by opening the exam anxiety data file, and we've looked at this before in class when we were looking for problems with normality. And we want to correlate among these three variables: the revision time, or how much time was spent studying, the performance on the exam, and reported anxiety level. So we're going to create a correlation matrix, and we're going to choose correlate from the Analyze menu, and then select the bivariate type of correlation. And we get several options here for the Pearson's product moment correlation, and you can read more about the naming of that if you check out the document I've put in our Desire to Learn page. And then the non-parametrics, the Kendalls Tau and the Spearmans Rho. We'll take a look at those a little bit later on. So to look at the correlation matrix among all three of these variables, just drag them into the variables area. And you guys might not have this option depending on how you acquired your copy of SPSS, but if you click on Bootstrap, I've got the Mac version that actually has bootstrapping in it, and if you say check the bootstrapping box, it's going to create a confidence interval for the value of the correlation coefficient, and it's going to estimate that using bootstrapping procedure by resampling your data set 1,000 times with replacement, right? So it's possible to get the same score again every time you select a score for one particular sample. We're going to do that 1,000 times. Field recommends using the bias-corrected accelerated confidence intervals. So I'm going to go ahead and click that. We're going to leave everything else set to the default. If you click Continue, then it'll automatically do that, and this computer does it pretty quickly. So let's click OK and see what we get. All right, so this is what the output file looks like. You have three variables listed: revision time, exam performance, exam anxiety, plotted against themselves, time spent revising, and you'll notice that the value of the correlation coefficient when you correlate time spent revising with time spent revising is 1, and that's what it should be because because of what we learned about in class with the variance and the cross product deviation. So this is the correlation coefficient relating time spent revising with exam performance. So that's a positive relationship. You would expect the more time you spend studying, the better that you do. We get double stars here. We're significant at the 0.01 level. This is our p-value. It's not actually 0, but it does go out pretty far. It gives you your n, and let's just look at the third comparison, which is time spent revising versus exam anxiety. This is a negative relationship, as you would expect. You spend more time studying, you're less anxious about the exam. This is the p-value associated with that correlation coefficient r, and it's very, very small. So it's less than, well, all the digits that you see there, less than 1 at the end of all of those. The other numbers that you see for exam performance and exam anxiety are simply repeated. So this is exam performance versus time spent revising. You get the same correlation coefficient as you do comparing time spent revising and exam performance. It's the same comparison with the same p-value. Similarly, when you compare exam performance and anxiety, that's the new value. That's the one that we hadn't done yet. So we get the a negative relationship here. People who are more worried actually do worse on the exam. That actually stands to reason. So here's the p-value associated with that one. All right, very low as well. So we have three correlation coefficients: revision versus performance, revision versus anxiety, and performance versus anxiety. And really that's all that we need to know. This final one actually repeats things we already did know. So exam anxiety and time spent revising we looked at earlier, and exam anxiety and exam performance we already looked at up here. So this last one repeats information we already knew. This one, well, that's exam anxiety versus itself. Right, the only numbers that we haven't looked at here are the confidence intervals, and what I'm really interested in here are the lower and upper bounds of the confidence interval, right, that we are 95% sure that this interval contains the true population value of what? Of the correlation coefficient. So this is our point estimate, 0.397, and here's our 95% confidence interval. It's somewhere between 0.26 and 0.52. You'll notice that this interval doesn't contain 0. And if the 95% confidence interval does not contain an R value of 0, then you would reject the null hypothesis, which is that this correlation coefficient is equal to 0. Right? If there's no relationship between those, then that would be your null hypothesis. And because the 95% interval doesn't contain 0, then you know that it's significant at the it's significantly different from 0 at the 0.05 level of significance. Similarly, for this one, our point estimate of R is 0.71, and our interval ranges from minus 0.47 to minus 0.86. This interval doesn't contain 0 either. 0 falls outside the interval, outside the 95% confidence interval, so we would reject the null that this is equal to 0 at the 0.05 level of significance. You know that if 0 falls outside your 95% confidence interval, then you would reject the null at the 0.05 level of significance. Finally, we'll look at this interval here. This also does not contain 0 as the interval. Because it's bootstrapped, right, you're going to get slightly different numbers every time you run this analysis. We could run it again and show that this interval might not have exactly the same values. But it's quite likely the case that if you rejected the null based on this p-value that's associated with your point estimate, that 0 would not be contained in your 0.95 interval. All right. Let's take a look at another data set here. We're going to open the file called The Biggest Loser. And there it is. Sorry, The Biggest Liar, not The Biggest Loser. Biggest Liar. And this is about people who placed in a storytelling contest versus their creativity. You would think that more creative people might do better in the contest. Let's find out if that's true. It's not appropriate to use the product moment correlation coefficient here because these are ranked data. So if and you can see that it's an ordinal variable. So if we drag these into the variables field, it'll let you do the Pearson, but I think it'll let you do it. We're going to use Spearmans Rho. We're going to bootstrap this one as well with the bias corrected accelerated method. And when we hit OK, we get a similar sort of table. So this is Spearmans Rho, and we're plotting creativity against itself. Of course, the correlation coefficient is 1. Against the position in the contest, we get a correlation coefficient R of minus 0.37 that is significantly different from 0, right? So it's a significant predictor, it's a significant relationship. And if we look at our bias-corrected accelerated 95% confidence interval, you'll notice that 0 is not contained in the interval, which means we would reject that null that R is equal to 0 at an alpha of 0.05. Right? 0 is not contained in the interval, and so it's a significant correlation. This gives you the bound, the upper and lower bound that we're 95% sure contains the true population value of R. Spearmans Rho is one non-parametric correlation you could use. The other one that I hope, had time to talk about in class is Kendalls Tau. Tau is superior to Spearman when you have a small data set and there are there's a number of rank ties, so scores tying for the same rank. If you look at the data set, yeah, there's a lot of ties here because many people placed first in this contest. I assume over several years of the contest, many people placed second. So there's a lot of tied ranks in this case. So let's use the Kendalls Tau and see what happens. We're going to bootstrap this as well. All right, that's already set. Hit continue. Okay. We should see that the R value is pretty close, right? It's a little closer to 0, but it's still significant. And again, that 95% confidence interval does not contain 0, so at the 0.05 level of significance, we'd use this information to help us reject the null hypothesis. All right. The next type of correlation we're going to look at is the point biserial, and this is when we're using a dichotomous variable, when one of the variables is dichotomous, and we see that in the PB core data file. So if you open PB core, we'll see that we're looking at gender of the cat and I guess the time that's spent away from home, and we're going to use this first coding of gender. Let's look at the codes here, the numeric codes. So here the variable gender is coded with 1 is equal to male and 0 equal to female. We recoded it under this separate variable backwards, right? So 0 is male and 1 is female. All right, we'll come back to that in a second. So now let's look at the bivariate correlation between the gender of the cat and time away from home. Can you do that? Can you have a categorical variable as your predictor? Absolutely. Totally legal in Georgia. Again, BCA confidence interval with 1,000 samples bootstrapped, and we'll take a look at what the output file looks like. Here we go. All right, so gender of a cat does predict the time away from home with a positive correlation coefficient 0.378. All right, and if 1 was male and 0 is female, that means that as you increase from 0 to 1, right, that predicts more time away from home. That's the positive relationship. So you got to keep in mind how you coded those data. It is significant here, and if we check that 95% confidence interval, 0 is not contained within our 95% confidence interval, so we'd reject at an alpha 0.05. Here's our point estimate with its associated p-value. Just for fun, let's do this analysis again, except let's use the recoded variable of gender, remember, which was coded backwards. So 1 is female and 2 is male. What do you think will happen to the correlation coefficient, the value of the correlation coefficient? Let's find out. So we're going to use recoded gender here. Still bootstrapping. Time away from home. All right. So as you might have suspected, the magnitude of the correlation coefficient is exactly the same as it was initially, but the direction has reversed, and it means that the smaller the value of the code for the grouping variable gender, the more time spent away from home. And that makes sense because for that one, 0 was male, so the more close to 0 that you get, the more time you spend away from home. All right. Once more, the bootstrap confidence interval. Hey, wait a minute, shouldn't these be the same as they are up here? Well, they're negative, but the values aren't the same. Why not? Because they were bootstrapped, and because you randomly selected those 1,000 samples, you didn't get the same value. It's pretty close, though. You did so many samples that it's really, really close, but not exactly the same. That's because it was bootstrapped. All right, the last thing that we're going to look at is the partial correlation, and we're going to go back to the exam anxiety data to look at this. Partial correlation allows you to look at the relationship between two variables while controlling for a third. In this case, we're going to look at how exam performance is related to exam anxiety while controlling for study time. So to do this, we choose partial from the Correlate menu under the Analyze menu. And we're going to compare exam performance and exam anxiety with time spent revising. We're going to bootstrap this, that's already set, but under the options we're going to check the zero order correlations box. What this is going to do is give us the correlation matrix of all three of these, as we saw earlier, just to see how they're related to each other without controlling for anything. And then it'll give us a separate analysis comparing these two while removing the variability that's from both of these distributions that's associated uniquely with time spent revising. We took a closer look at that explanation in class. And there's a document posted in the Exam 1 folder to help you out with that. Okay, so it's running that partial correlation 1,000 times, right, with those different samples taken from our own data set. It takes the computer a little bit longer to do that. Now we're done. So let's look over the output menu here. So the top part that you see is the zero order Pearson correlations, and it's indicated by this subscript, superscript A. Cells contain zero order correlations. So this is this is what we did before. Exam performance correlated with itself, with exam anxiety, and exam performance correlated with itself, with exam anxiety, and with time spent revising. These are the same values that we had before. Similarly, exam anxiety correlated with performance, with itself, and with time spent revising. And this third one just repeats that information that we already knew. So here are those correlation coefficients again. They're the same as above. Here's the p-values. They didn't change either. The bootstrap confidence intervals are different because they were bootstrapped and they were randomly using 1,000 random samples with replacement and not the same samples that we saw above. So if we go back to our very first correlation coefficient, you'll see the interval for exam anxiety and time spent revising. It's not the same as this one for exam anxiety, time spent revising. It's close, but not exactly the same. On the bottom, we see for control variable time spent revising, so we're controlling for study time in looking at the relationship between exam performance and exam anxiety. We see that the relationship goes in the same direction, right? It's negative. If you're more anxious, then you didn't do as well. And it's still significant, right? Here's our p-value, and the 95% confidence interval that was bootstrapped confirms that, although it's really, really close. We would still reject that null at an alpha of 0.05 and say that this R value here is significantly different from 0. But it's much less than the original relationship. In fact, it's close to half the magnitude that it was before when we remove variability that shared between exam performance and time spent revising. So that's how controlling for another variable statistically can change the relationship between a predictor and a criterion variable. All right, that's it for correlations in SPSS.